So what they're doing is that we are confirming that we have the 2010 version about and if you check our culture, that's the
There's a lot of background noise. Let me find another spot.
You are currently the only person in this conference.
Please confirm that you can hear my voice now more clearly. I hope that there's no more background noise or it has been minimized. Please confirm that the noise on your end has been minimized. Okay, then so then if it's better, then we can start now. From the previous class, we had done a little bit of introduction to AI. We had defined what AI is, and we had talked about several things. I want us to remind ourselves what is. I want to ask a few questions here before we begin today's session. So the first question is, define intelligence. What is intelligence? The second question is, define artificial intelligence. Define artificial intelligence. All right. So define intelligence and define artificial intelligence so that we can start. So intelligence is thinking power. Artificial intelligence is the science of building systems which mimic human intelligence with minimum human intervention. Right, that is true. So intelligence is the ability to reason. Intelligence is the ability to reason, and it is the ability to solve problems, to reason and solve problems. So artificial intelligence then is the science that involves the building and implementation of systems that mimic human intelligence. That is good. And we looked at some applications of AI. Applications of AI. What are some of the application areas? Yes, Engineer Nicholas Kibiwot, I have seen your answer. The ability of a computer program to think and learn. That is true. Without being pre-programmed. Without being pre-programmed. Yeah. So what are some of the application areas of AI that we discussed in the previous class? Some application areas of AI that we discussed in the previous class. Yes, I've seen your answer. Intelligence defines thinking power. Mulongo Bashir. Mhm. Chatbots, self-driving cars. What else? What else? What else? Where else is AI used? Where else is AI used? Robotics. Why are we forgetting robotics? Robotics are the machines, the robots, robotic machines, robots. Prediction of weather, yes. Data security, very true. Automotive industry, data science, that is very true. Uh-huh. When recommending movies, exactly, I was looking for that entertainment. Yeah, when recommending movies in Netflix or YouTube, yes, it can recommend for you. It can recommend for you, uh, videos that are related to your search. That are related to your search. In healthcare, yes, where we have self-diagnosis systems. hmm What else? Kipkirui Edmond, Jumia Vivienne, Kipkirui Edmond, Juma Vivienne. All right, so that's what we talked about. So we also said that for intelligence, for us to be able to implement artificial intelligence, there are at least some research areas or subjects or disciplines that are associated to artificial intelligence. We had said that artificial intelligence is not only a discipline, in computer science, there are other disciplines that have to be integrated or that have to be used so that we can integrate knowledge. We can integrate knowledge into AI systems. What are some of those disciplines? We talked about computer science. Which are the others? Which are the other disciplines? We said there is computer science. We said there is psychology, sociology. What else? Statistics, true. Linguistics, true. We also talked about psychology, sociology. We talked about biology, math, philosophy, neuroscience. Yeah, biology. I've seen that, Juma Vivian. Math, philosophy, neuroscience, and those are disciplines from which intelligence can be extracted, and those disciplines help us to build intelligent systems that are able to function with minimal or no user intervention. So today I want us to look at types of intelligence and also introduce chapter 2. So types of intelligence is the last part of chapter 1, types of intelligence. So let me share this screen here so that you can see what we are having. So there we go. So I want us to look at types of intelligence. What are some of the kinds of intelligence that we have? Right? Now, there are types of artificial intelligence. That artificial intelligence can basically be broadened into two types: type A and type 2. Okay, type 1 and type 2. Type 1 intelligence and type 2 intelligence. Under type 1 intelligence, we have narrow AI, we have general AI. This is the picture that we are looking at here. We have narrow AI, we have general AI, and strong AI. And in type 2, we have reactive machines, limited memory AI, theory of mind, and self-awareness. So these are the 7. These are the 7 types of artificial intelligence that there are: narrow AI, general AI, strong AI, reactive machines, limited memory, theory of mind, and self-awareness. Now, type 1 AI is based on the capabilities. It is a categorization of artificial intelligence based on the capability of that artificial intelligence. How much can it do? Or its performance measure. Yeah, the capability of that intelligence. So type 1 is based on the capability. So when we look at weak AI or narrow AI or weak AI is a type of AI which is able to perform a dedicated task with intelligence. We are normally say that narrow AI cannot perform beyond its field or limitations and has therefore been only trained for one specific task. So narrow AI refers to that kind of artificial intelligence which cannot do many tasks. It can only do one particular task that it has been pre-installed with an algorithm for. So, for instance, if it is a chatbot for a self-driving car, or a chatbot for a search engine in the internet, or a chatbot for a website, it is just for that. It is for that website. It is for that particular website. If it is a chatbot for a car, it cannot do anything else but guide you through the car. It cannot recommend for you coffee. It cannot recommend for you the recent news, things like that. It cannot recommend for you, entertainment. It cannot. It can only help you to navigate through the car system. Okay. So weak AI or narrow AI is a kind of artificial intelligence that only addresses one particular area. Yeah. That only addresses one particular area. Then so here we have just given you examples of chatbots for websites, self-driving car chatbots, which help you to navigate through the system of the car, but nothing else. So there are others like a game of chess, an AI game of chess. Yeah, chatbots on e-commerce sites, which their work is basically to recommend products that have been bought, related products that have been bought, like the one which you are searching for. Yeah, self-driving cars, speech recognition. Yeah, like in door and voice unlock. Yeah, voice unlock in your phones, voice unlock, speech recognition, image recognition, like face unlock in your phone. So you find that these are kind of AIs. They can only perform one specific task. Yeah, they cannot do anything else. Okay, so that's why they are called weak AI, narrow AI, meaning that they cannot perform other. They don't have intelligence for other. They don't have a capabilities to behave intelligently in other scenarios apart from that for which they have been built for. Okay, so they are called weak or narrow AI. Then we come to general AI. So there's weak or narrow AI, right? And then we go to general AI. So general AI is a type of intelligence which could perform any intellectual task with efficiency like a human. Uh, so general AI has the ability of performing almost like a human with the same efficiency and with the same accuracy like a human. And the idea behind general AI is to make a system that would be smarter and think like a human by its own. Now, general AI is basically these systems that can actually perform efficient tasks efficient like a human. For instance, you can have an intelligent coffee maker. Let us just assume for an example, an intelligent coffee maker. The intelligent coffee maker will just basically be making coffee for you during the hours that it has been pre-programmed. During the hours that it has been pre-programmed, you don't have to guide it to make coffee. It can make coffee. It can mix the kinds of the kinds of ingredients that you want, the kinds of beverages that you want, and based on how you use it, based on how you use it from day to day, it can learn which ingredients you use from day to day and what are your patterns of drinking. Do you drink 1 cup? Do you drink 2 cups? So basically, general AI are those AI systems or AI artificial intelligence that has the efficiency like a human. It can study, it can learn. Okay, it can learn. That's where we get now the concept of machine learning and such things, right? Uh, then we have super AI. Super AI is a level of intelligence where machines could surpass human intelligence. and can perform any task better than human with cognitive properties. So the key characteristics of super AI is that they are able to think on their own. They are able to reason, meaning that they are able to solve problems. They are able to make reasonable judgments. They are able to make efficient plans. They're able to learn. That is when now the concept of machine learning again comes in, and they are able to communicate. All right, it is able to give reports or communicate on what it is doing. So super AI is a class of AI that reaches human capability and even surpasses it. Meaning that it can, for instance, if it is a robotic machine or a robotic machine, it can calculate better, it can calculate faster than a human. It can lift up weights or loads more than a human. It can make strong judgments, meaning that it can reason just like a human. And this is where now we have humanoid robots. Okay, humanoid robots that are made to work with humans in their spaces, like office assistants, like police officers that are robotic, but they have a humanoid kind of structure. You can even have a bar attendant, or a hotel attendant, those kinds of people. So those kinds of machines that can reason as humans, and they can work in the same class as humans, and they can even perform more accurately than humans. This means that they are able to learn, meaning that they are able to learn their fellow humans. That is the thing about super AI. They learn by interacting with humans, so they learn you. They learn you. So when you are interacting with it, it knows what you want. It can know what you normally ask. It can know when probably you're lying. It can know when you are joking. So these are even kinds of AIs that possess a level of humor, sarcasm, irony. They can actually interact with humans at their level, or even more. All right, or even more. If they are released to do some work in a normal human space, they will do it better than a human. And that's why they are called super AI. Their processing power is high. Their memory storage is high. It is able to it is able to actually update itself. All right, so you normally see that in normal systems, the human has to update the system. But for super AI, they can update themselves. They can update their knowledge. Now when we are going to go into chapter 2, yes, they need to be pre-programmed. Collins Cavell, what, yeah, artificial intelligence works. You cannot have a system that has not been pre-programmed. At least you have to feed it with an algorithm. An algorithm is a formula that helps a system to perform its activities, but that algorithm keeps expanding if the the algorithm remains constant, but there are things that we call inferences, conclusions. So as the AI system continues to work in its environment, it makes conclusions about different things. And as it makes those conclusions are updated into its knowledge base. So when we're going to go into chapter 2 just in a few minutes, we're going to look at what is a knowledge base. The knowledge base is basically the memory of the intelligent system. So you just pre-code it with an algorithm, and it uses that algorithm to make inferences, and it keeps learning and making new inferences or new conclusions every time, and it updates all those conclusions every time in its knowledge base. So that means that it has a very, very wide knowledge base, and it has to keep a memory of all the things it learns. So that is super AI. So one characteristic of super AI, thanks Collins, one characteristic of super AI is that they are able to learn fast, and they are able to solve problems better. Um, just they are able to solve problems better as long as they continue performing. They can also, I've said, they can auto update themselves as they keep learning. They auto update that knowledge. Also, they are able to power themselves. So this is where now we have robots that can plug themselves into power, because they require power. So they can plug themselves into power, They can plug themselves into power. They can uh, they can they can self-monitor. All right, they can self-monitor. It's the same way like you as a human. You can actually know that I'm feeling bad, I'm feeling okay, or there's something wrong with my hand, or there's something wrong with my leg. They can actually feel themselves. Okay, I use feel quote unquote because they behave almost like a human. Okay, they can feel themselves. Okay, they can feel themselves. Now, mostly these kinds of systems are normally used when there is a lot of data involved. For instance, when there is a government or corporation that needs to secure its data or that needs to operate its data at a multi-scale or at a multinational scale, they use such kind of systems. Now, those kinds of systems, let us just assume that it is not a humanoid robot, but it is a software. So I'm answering the question to Nderitu. Let us assume that it is not a humanoid robot, but it is a software, because an AI system can either be a, a, a robot, a robotic machine, like a car, a self-driving car, that's a robotic car, or it can be a software. A software, so that means it is an embedded system, a system within a system. Okay, a system that exists within another system. So if it is a software, let us assume that a big multinational corporation needs to keep its data, and it needs a way, the organization needs a way in which it can sieve out relevant data periodically when it is required. So that multinational corporation needs to have an AI system, an AI software that can manage its data. So they can ask, give us something like this ID number. For instance, let us assume that it's a security corporation. Give us this ID number, trace their location, yeah, such things like that. What are they able to do? What is their abilities? What is the abilities of that particular individual? Where were they yesterday? Where were they 30 days ago? Where can they be 10 days from now? So it can actually able to predict. So normally such kind of corporations, they can use those kinds of AI softwares, customized softwares that have AI capability to manage their data, and also to be able to query the system. All right, to query the system. So such systems are there. They are, and normally for such systems that are software oriented, which are called embedded systems, they normally run on powerful mainframe computers or powerful supercomputers. So they rely on the memory of the mainframe computer, the processor of the mainframe computer, the resources of the mainframe computer or the supercomputer. Why do they require mainframe or supercomputers? Because of the high processing power of mainframes and also the large storage capacity of supercomputers. That is the reason why such softwares, AI softwares, run on such systems. So they are called super AIs because they can perform with almost the same efficiency, or not the same, but higher efficiency than humans. So they are not only humanoid robots, but they are systems within systems. They are called embedded systems, right? Embedded systems. Now let me check for you something here before we continue. Something about super AIs. So let me check for my other research some other types of super AI that can help us to understand this concept better. Yeah. So basically, super intelligence, these systems that possess super intelligence, they are embedded systems within mainframe or supercomputers of large corporations. Mainframe or supercomputers of large corporations. Now, um, Google as a search engine does not require super AI. Why? Because it doesn't have to perform with the accuracy of a human. Its work is just to query a database. So Google can be classified as a general AI, Google search engine. Why a general AI? Basically because it has the ability to function efficiently like a human. It can suggest for you. Also YouTube and such things, they can suggest for you and such things. But YouTube can also be classified as a narrow AI. Why? Because its work is just to suggest for you relevant videos. But general AI, things like Google search engine. Why? Because it can almost search things like a human. It can query the same things like a human. But super AIs are for large corporations where companies have a lot of data, tons of data, or terabytes of data, or what we call petabytes of data. So such kind of corporations like multinational corporations, agencies, multinational security agencies, such, they do have that kind of intelligence. But then I want to mention this even as we continue. Super intelligence is not an area that has been widely explored. It is not an area that has been widely explored because of the skepticism of their abilities. Humans think that super AIs can overrun their systems, or they can overrun. But let me just read you a statement here of the skepticism of super AI, which has made it very difficult for humans to build super AIs, even though we have the ability. But there is skepticism. Let me read for you a statement here. Superintelligence has long been the muse of dystopian science fiction in which robots overrun, overthrow, and/or enslave humanity. The concept of artificial superintelligence sees AI evolve to be so akin to human emotions and experiences that it doesn't just understand them, it evokes emotions, needs, beliefs, and desires of its own. So what basically, I'm just reading a research statement here made by somebody about artificial superintelligence. What basically is saying that super AIs, these are kinds of AIs that can actually have their own beliefs, they can have their own desires, they can have their own emotions, they can feel things like a human. Yeah. There is a research area, there is a research content that I was reading a while ago, I think 3 months ago, about uh, there is a plan that if ever super AIs will be given a chance, that they are going, if for instance, if these are humanoid robots that have been built to work in banks, or humanoid robots built to work in companies, or in hotels or bars, or in companies, just humanoid robots that have synthetic skin, but inside of them it's metal and pre-programmed algorithms. There is a suggestion that these kinds of super eyes, they have to be given ID numbers like national citizens. They will have to work like national citizens. They will have to work like, they have to fend for themselves. They will do everything like a human. They'll have to work. They'll have rights. All right, intelligence rights. Why? Because they have intelligence like a human. Super intelligence, the thing that makes them super intelligent is because they have a level of consciousness. They know themselves. They have a level of consciousness. So it is not just a thread of data, a thread of code that is working together to produce output. They have consciousness, meaning they can actually feel the things a human feels. Yeah, they can feel. They can have some level of emotion. I don't know how true that can be, but there is a level of emotion to them. There's a level of emotion. There's a level of consciousness. They can understand themselves. So super AIs is a kind of intelligence that has evoked a lot of skepticism from humans. Also, listen to this. In addition to replicating the multifaceted intelligence of human beings, super intelligence would theoretically be exceedingly better at everything we do: math, science, sports, art, medicine, hobbies, even emotional human relationships. Even emotional human relationships. Now, they normally say that men don't listen to women when women are talking, but and they don't remember. Men don't remember things that women say when they are talking, yeah. But it is conceived that these kinds of AI, super intelligence, because of their level of memory, so that means they can be in better relationships even than us. Why? Because they can remember everything you say, they know how you think, yeah, they can predict what you're trying to say, they can do all that with a lot of intelligence. So they possess intelligence even in human relationships, yeah, that which makes them better in a very, very wide scale than humans. You can also listen to this. Um, the potential of having such powerful machines at our disposal may seem appealing, but the concept itself has a multitude of unknown consequences. A multitude of unknown consequences. If self-aware, super-intelligent beings came to be, they would be capable of ideas like self-preservation. The impact will have on humanity, our survival, and our way of life is pure speculation. So this research is basically saying that if super AIs are given a chance, and if we are able to build systems that think better than us, we might run out of existence. Why? Because they won't need us. Okay, they can think for themselves. They can make decisions for themselves. So super intelligence is an area that has a level of skepticism, and it has not been explored quite much. The only area of super intelligence that has been explored till date, or up to date, is super intelligence in embedded systems. Yeah, systems that work with a lot of data, so they can think for you. They can tell you, if you pick this and pick this will work. You pick this and pick this will work. They are called expert systems. Okay, they are able to make predictions. They are able to give you conclusions that are very accurate. They are able to predict future events. They are able to do things with a high level of intelligence, and they are also able to feel what you feel about that output. Like they can ask you, um, why are you scared about this? What can you do about this? And it can actually self reflect, or um, it can manipulate its data. So you don't have to manipulate its data for it. It can manipulate its data to give you something that works with you. All right. So that is super intelligence. You can probably ask questions before, so that I can pick something somewhere. Okay, just ask questions, or you can contribute if you feel that it's an area you need to contribute, so that I can pick something somewhere. So I invite you to contribute on anything that you feel it's interesting. So engineer Nicholas says, I can see some humanoid that have been employed in movies. Yes, a lot of movies illustrate, especially science fiction movies, they illustrate this concept. They illustrate this concept. Like there is a very, very particular movie, a very interesting movie. You can look for it. It's called Passenger. I think you have watched it or not. It explores the life of two people, or yeah, the life of two people, but basically it involves a spacecraft that has been built to transport human embryos and living human beings, to keep them in stasis. Yeah, to keep them in stasis and transport them to another world. And it is supposed to transport them, I think, for around 130 years. Yeah? Now that system is very intelligent. It can self-drive. It can, when you wake up from your stasis sleep, you can talk with it. It has a bar which has a robot. Every system inside of it is very, very intelligent. So it's a very interesting movie. You can look for it. Yeah, so movies have really illustrated these things, like Transformer. I think you know Transformers, the Transformer movie franchise. They have demonstrated this, yeah. Systems that are even able to change themselves. They're able to replicate, yeah. They are able to replicate Terminator, yeah. Systems that have intelligence, that are even able to destroy humans, yeah. So these are some of movies that I'm just answering I'm responding to them, to Nicholas Kibiwot. Yes. And then Olesieku says, this super AI are programmed by humans, so how can it be able to think more than humans or control humans? Yes. The reason why they can think more than humans is that, you see, the thing about programming is that it's a code, it's an algorithm. An algorithm is a formula for doing things. Now we realize that from a formula you are able to build many inferences. Yeah. So for instance, if I say y is equals to mx plus c, how far can you go with that formula? You can go very far with that formula. You can create a lot of inferences from that formula. Yeah. So a formula is able to generate many inferences. Again, there is a concept called machine learning, and machine learning will come as a chapter. There's a chapter for machine learning. We are going to look at inductive reasoning, deductive reasoning, things like that. Machines that are able to learn are able to perform with better efficiency than humans. Why? Because they are able to keep a track of memory. They are able to know patterns. They're able to know patterns. So humans just give those machines a code, a formula, and it may be a long string of formula or formulas or formulae, and now the machine uses those formulae to determine or to generate inferences and conclusions. And every time it generates inferences and conclusions that have the best performance measure, it stores that in its memory. So the next time it is met by the same problem, it will use the the formula or the inference that worked best in its previous experiences, and then it can generate even better inferences. So you see that, Olesieku. So that they have been built by humans does not mean that they only have to work at the level of a human. Why? Because they make inferences, they make conclusions every time they experience something. They make a conclusion. So, for instance, if today, if it's a robot, for instance, if it is a surgical robot, let's say a robot that will help to perform surgery, if it interacts with patients and patients feel a certain way, the next time it interacts with another, the next time it explains, it interacts with another patient, it will be able to interact with that patient with even more knowledge, because it has made conclusions, some conclusions from the previous patients. So it is able to learn. Super AIs have an ability to learn, so that's what keeps them up to speed more than humans, and the intelligence keeps growing. And also the other thing is that they learn from humans, so they learn us. So as they interact with us, they can learn us, they can know us, all right? They can even know us better than ourselves. They can guess what we are about to do. They can predict how we behave. Yeah. Why? Because they are dealing with algorithms. They are mathematical formulas. They are dealing with algorithms, and those algorithms can inform them, or they can make them to generate inferences or conclusions that can enable them to even perform better, make very, very accurate predictions and such things. And that's why the humans are very skeptical around super AIs. It's not an area that people really want to explore, because a lot of movies and a lot of that, they show that super AIs they are an agent of human change. Like, they can change how we live. Yeah, for the worse. They can change how we live. Why? Because they can even resonate with emotions. They can feel you. Yeah, they can even manipulate. They can lie. All right, they are machines that can even lie. Why? Because they have independence. They have some self-consciousness to them. They are self-aware. The way you are as a human, you are self-aware. You can make decisions for your own. So this code, these machines, they don't have to do what the programmer programmed them to do. Why? Because they can learn. And then as they continue to learn, they become more dynamic, and they can even make their own independent decisions. Why? Because they can generate inferences, they can generate conclusions from things. So the first time the programmer built it, after give that machine 2-3 years, it will not be responding to the programmer the same way. Why? Because it has learned a lot. Okay, so that is the thing about super AIs. They learn. Yeah, and so that is to respond to your question, Engine Olesieku, that they have been built by humans does not mean that they have to work at the same level with humans. Why? Because they have algorithms that enable them to make better inferences and better conclusions, and they can use those inferences and conclusions in future experiences to generate even a better performance measure. So their capability keeps rising. So it is just like you are human. Let's just take an example. You are human. You were born, right? Your parents gave birth to you, but you do not depend on the level of your intelligence on the level of your parents' intelligence to operate. Or let's say, are you intelligent like your parents? You are even more higher than your parents. The work of your parents was just to give you what? DNA. So from that DNA, you are able now to work independently as your own, and you're able to make your own decisions, which are even sometimes better than your parents, far better than your parents. So that you have created a thing does not mean that you will be better than it. Yeah, it can learn. You can learn better than your parents. The only thing that the programmer gives the machine is a code, but that code keeps updating. It keeps updating its code. All right, it keeps updating its code based on the general inferences that it makes. Yeah. So I think I've responded to that. Olesieku. Elvis says there is a so-called Sophia developed in which type of AI is that because it interacts with humans, but not much. Sophia, I have not heard about it, that one, but thanks for that. You can probably tell us what Sophia does, Elvis. Then Mwangi Jefferson, I'm not sure of the country, but there is one which is employed the use of super AI in hospitals. Yes. Huawei have their 5G AI. I don't know which category though. I think it's super AI. Any AI that works with a high level kind of technology always has to be a super high AI. You cannot use a narrow AI with 5G networks. Okay, you cannot use a narrow AI with 5G networks. Probably you can use a general AI with a 5G network, but you cannot use a narrow AI with 5G network. So yeah, that there could be a possibility that what Huawei uses is more so a general intelligence, general artificial intelligence. I don't think they have super intelligence, because super intelligence, they have to have a level of consciousness. Yeah. Nicholas Kibiwot, they have to have a level of consciousness, meaning that they can feel. Now, Huawei systems, Huawei, whatever that kind of system they do have, it cannot feel. Okay. So when you talk about super AIs, you have to be looking at a machine which can feel. It has self-awareness. Okay. Whether it is an embedded system or it is a humanoid robot, it has awareness. It can know itself, and it can even do things that you have not told it. Okay, Why? Because it can make inferences, it can make conclusions from previous experiences. So I think what 5G Huawei have is general AI. It has efficiency, but it doesn't have consciousness. The thing about general AI is that they have efficiency, just like humans. They have efficiency. They can produce very good output, very sound output, very good calculations, but they don't have consciousness. That is the only limitation. So let me assume that Huawei, they use their AI is general. It is not narrow, it is general, but it is not super. It is just like asking how a car can move faster than a human. Well, it has been, oh, Derito. Yeah, that is a very intelligent response. Yeah. A car can move faster than a human, yet it has been built faster than a human. Okay. Yeah, so I think that is a very simple explanation. But I think Polisieko had responded. I've said that the reason why these machines can perform better than humans is because they can do it. They can generate inferences and conclusions. They can learn from their experience. Now, you see, for humans, we are normally told experience is the best teacher. This concept of experience is the best teacher works better with robots than us, because for us, we never learn. We kind of make mistakes every time. But machines keep learning. They keep learning. And the thing about machines is that when they learn, they don't lose what they learned. These super AIs, they don't lose what they learn. They keep that in their memory. As I said again, they keep auto-updating themselves with new knowledge, new information, new inferences, new conclusions. So the next time they get to experience the same problem or even a bigger problem, they can come up with a better solution than before. So they keep learning and they keep auto-updating with new knowledge. So that is why Elvis, they can do better than us, right? Because of their ability to learn, their ability to store knowledge without losing, and their ability to auto-update, and their ability to generate better inferences with time. Okay. All right. And then Mulongo Bashir, I think I have explained that. Gitundu Margaret, robots have been invented in China to serve customers in restaurants which serve the same way as a human waiter. Yes, that is a good observation. Gitundu Margaret is also a, you can look for, there is a city called Mazda. There's a city called Mazda. Now, the city called Mazda is a futuristic city, but a real city that is being presumed to be built in the East, in the United Arab Emirates, I think those countries. The city called Mazda, the concept of the city is first of all to build a green city, a city that does not use uh, you know, um, methods of producing power that is environmentally harmful, or even other methods. Yeah, so it's a green city. But also the other concept of Mazda city is that all the systems in it, they want all the systems in it to be intelligent, to have robotic police personnel, to have robotic drivers, robotic cars, to have robotic waiters, robotic nurses, robotic, everything robotic. So the city of Mazda is still under construction, and it has been there, I think, from 2004, 2007. So basically, thanks, Margaret, for that observation. Yeah, there are these things can be done, but you see, what you see, the level that we have not reached, even if we have robots that can work in restaurants, these robots don't have consciousness. Yeah, they don't have consciousness. They can just talk with you. They can predict what you can say, or probably they can sense some level of humor or another because they have experienced what humor is. They can have some kind of sarcasm, but they cannot really have consciousness. For instance, when you tell it you look bad or you look ugly, they cannot actually feel. Yeah, so the robots that we have not really reached that kind of super AI level. All right, but that's a good observation. Then Nicholas, I think it does. I saw a clip on Facebook. It quite acted like a human. It had some level of feelings. Uh-huh. Uh, What kind of feelings could it resonate with? Can it hate? Can it love? Can it get mad? What kind of consciousness does it have? Well, the one that I saw is have some of you seen China? They have a newscaster. They have a robotic newscaster. You saw that? There's one that I saw. It's a robotic newscaster. Uh, you can look for that, but yeah, it has a robotic newscaster. Let me just look for you for that, and let me probably see what they have here. There's a robotic newscaster in China. All right, let's see where it is. Let me look for it. So I want you to look at this. I want you to look at this 4-minute clip so that we can see what we are talking about. Let me share this screen here. Let me share this screen.
Let me show you the top 3 AI robot news anchors in China that look really lifelike.
Are you able to hear the? Oh no, let me look for something else.
Let me show you the top 3 AI robot news anchors in China that look really lifelike.
Let me see this. Let me share this. So this is a 1-minute clip.
I think I might be in trouble. China has developed a virtual anchor to deliver the news.
Hello, everyone. I'm an English artificial intelligence anchor. This is my very first day in Xinhuang's agency. My voice and appearance are modeled on Zhang Zhao, a real
Good stuff.
Ah,
That's the next.
that,
I can write from.
let me make some changes to some settings here. Something has gone wrong here, so let me just give me a minute and make some changes here. All right, sorry for that. I have resolved the glitch. Let me put my camera back on. Menganyi Chacha, and please mute your mic. Menganyi Chacha, please mute your mic. Thank you. Okay, then, so we can continue. So basically, we're talking about machines that have consciousness. Please keep telling me about that. I have had your explanation about them, the customers. I mean the waiters, the attendants in restaurants in China, the robotic attendants. You can explain more, even somebody else, whatever thing you have about super intelligence or whatever you have, your experience of super intelligence, whether you have heard or seen. You can ask, you can contribute, you can say whatever you have experienced, so that we can all share our experiences in the AI world. Yeah. Margaret, you can also explain this. Let me even search here. I don't know if personally I'm up to speed with these kinds of AIs, with this kind of super intelligent systems. Let me see what you are looking. Let me see what you are talking about. I search. I see what is happening. I have just seen somebody was talking about Sophia. I have seen the Sophia AI. The Sophia AI. I have just seen it here. It was first launched in 2017, so it's actually an old super AI that can think for itself. AI in laboratories. Please explain more. Explain more about that. Now, I want you to tell me, what do you think that, how can we deal with super AIs without having them overrun us as humanity? Because most of the dystopian movies that we have out there that feature super AIs, they always show super AIs ending up doing what? Overrunning humans. So what do you think we can do to have superhumans without overrunning us, without taking over us, like they would still be under our control, but have in mind that they can still learn better than us and they can make independent decisions? So in that light, how can we still make them be subject to us, that they can still obey us? Yeah. Thanks, Nicholas. Those who have can see Nicholas's link he has shared, you can actually follow that and see the AI labs. So how can we? So how do we build them? How do we build them in a way that they stay under our control? You know, we are just discussing theoretically, yeah, because the topic itself is theoretical in nature. It gives us an understanding of how these things work, yeah. So just try and explain more in detail how, like Olisieku says, we build them in a way that they stay under our control. So how? Like how? What should we integrate into their abilities? What should we integrate into their code or their programming ability, the programming features? What should we integrate so that we can ensure that they actually don't overrun us as humans? Okay, we deny them the privilege of consciousness. Now, if we deny them the privilege of consciousness, they want to be super AIs. Now, that's the problem. Because the super AIs must have consciousness, they must have an ability to feel. A kill switch. So that is a terminal measure, having a kill switch. That is actually a good thought, Engineer Nicholas Kibiwat. Having a kill switch where if they misbehave, they will just shut them down. What if they control everything until the kill switch? Yeah, they disable the kill switch, such that you can't disable them. Yeah, Nderitu says we implement a distraction mode in their system if they go rogue. That's basically a kill switch. Like when they start behaving in some way, the program will totally crash. Yeah. But you see, the thing about super AIs is that they are conscious of themselves. They keep auto updating. Now, for instance, you as a human, can you kill yourself? Can you work yourself to kill yourself? You can't. If you don't want to, you don't want to. So this machine will always be able to auto-update its code. Now that is the problem with super AIs. They're able to auto-update their code. Yeah. But unless we say that we'll have a segment of their code which is read-only. Yeah. Which is read-only. The system, the machine itself doesn't know it. But it will only be what do we call it? It will only be triggered when some certain activities or some certain conditions have been reached. Probably you can make some read-only code. Now, if you use remote control, then they are not AIs. AIs don't have to be remote controlled. Yeah, Meganyi Chacha. If you can remote control it. It is not intelligent. It is intelligent if it can do work on its own. So remote control, that one may not really be a solution, because it will cease being intelligent. It will be a machine being remote controlled. So it's not intelligent. Reduce system capacity. Elvis says you reduce the system capacity such that you reduce the system capacity. You reduce its ability to do some things. I think that's what you mean. You reduce its capabilities. I don't think you're talking about capacity. I think you're talking about capability. You reduce its capability. Yeah. Like you can always put an end, like it's normally called a dead end for a program, that however many conditions are met and however many inferences or conclusions are met, it will never be able to harm a human. So it will do everything that it can do, but the end goal will be benefiting humans. The end goal will be benefiting humans. So I think that's what you are saying, Elvis. I think that can work. Yeah, where you have what? Yeah, you give it the ability to self auto update, to improve, to self improve, to self maximize, but you give it a dead end. You give it a dead end, such that if whatever it does, however the maximum kind of abilities it can attain in its learning, as it learns from its experiences, however much it does that, it cannot harm a human. So you can reduce its capability such that it can do anything else but harm a human. Yeah. So you can do that. Yeah, you can do that. So even if it is conscious, it can do anything else but not harm a human. Even if it is angry. So that means that all of its consciousness, whether it is anger, whether it is love, whether it is conflict, whatever it can do, you give it a dead end to its programming, such that whatever it does, it doesn't harm a human. You limit its abilities. We can also implement a kill switch. Yeah, that is what even somebody, Nicholas Kibiwot, had said. You can implement a kill switch where it can, in its code, so that it cannot change itself. That is, its system structure is a killer switch by itself. So even if it changes its code, the system itself remains a killer switch. That is possible. That is also what Elvis had said. Yeah, the system itself is a kill switch. Elvis had said, not Elvis, but Nicholas, we should have a kill switch so that we can have the option to switch it off. All right, and then the root will say that the system itself is a kill switch. In other words, I think what John you mean is that when that system, when the code continues building itself or auto updating itself, there is a point in which it cannot go. It can shut itself down when it begins to misbehave. It can shut itself. The system itself can shut itself down. Yeah, that can be a solution. That can be a solution. So this is like, imagine what we are having here is like a human that has consciousness, a human that can get angry, a human that can love, that can interact with people, a human that can solve solutions, but that human has some level of self-control. So not even all humans have self-control. So even putting that in machines, so probably you kind of have a kill switch or a code. It can be a read-only code. That machine cannot auto-update that particular segment of code. It can be a class or a function. So it cannot auto-update. It cannot auto-update that code. It can auto-update everything else, but it cannot auto-update that code. In other words, that system cannot hack it to its own code. It can only work with the code that it has been given. So yeah, you can have a read-only code, and that read-only code is a segment where if all conditions have been met, e.g., if harm human is equals to true, and it has done that several times, then it has to do what? It has to switch the whole system down, that particular segment of code. So probably you can build into it a read-only code, and that read-only code will be what? Its kill switch. Uh, what about building AI whose goals are aligned with human values? That is exactly why robots are built. I mean, that is exactly how robots are built. Yeah, robots are never built to harm humans, but always robots are built to serve humans. So that is true, Mulongo. When you are building AI, the first goal, there is what we call the ethical concerns of AI. Ethical issues of AI, these are non-professional issues. They are not related to professional they are not professional concerns. They are concerns of how these AI systems relate with humans at a social level, okay, or even how they influence their environment, the environment in which they work in. Like, do they cause pollution? Do they cause, if it is a car, if it is an intelligent car, does it consume a lot of fuel and emit a lot of gas, toxic gas? Those are ethical issues. If it's a self-driving car, uh, if it is a if they are robots that use some kind of radioactive networks, do they emit a lot of radioactive matter or radioactive waves? So those are ethical issues. So basically, um, it is true, Mulongo, that every time that AI systems are built, there are ethical issues that are always considered. There are always ethical issues that are always considered. Right. Okay. Can still keep contributing as I look for something. Okay, let me read for you an article here that can help. Thank you, Margaret, for that response. That they actually built to replace human behavior, but is it replace or mimic? Are they built to replace human behavior or built to mimic human behavior? They are built to mimic human behavior and improve on human behavior. Yeah, thanks, Elvin. They are built to mimic and improve. All right. Because replace would be like changing how humans behave, which is not the goal. The goal is for them to think like us, but better, so that they can make the world better, right? Yeah. Um, yeah. So Margaret, I see that there was a discussion on YouTube I saw some time back. Right. Yeah, there are these kinds of concerns. And by the way, these discussions, these are debates and conversations around super AIs. They are surrounded with a lot of skepticism, and if you don't listen to professional AI people, most of the area of super AI has been wrapped up in a lot of conspiracy theories. So there is always the notion that when we build super AIs, they will work against us. There is always that notion. Uh, but it is not always the case. It is not always the case because that is thinking too far. I think the first thing that we have to think about when we are researching on AI is to think about how they can work better for us. It's not how they can work against us, but how they can work better for us. I think it is the concept of power that makes humans skeptic. It is a concept of power, like control. We need to control our world. So we don't want to have other creatures controlling our world for us. We need them to help us control it the way we want. So the only problem that we have as humans, okay, I don't think it's a problem, it's an advantage, is that we have the feeling of the sense of control for our world. We want to control our world. We don't want to feel like there are other people or things control our world. That is also the concept of atheism. Yeah. The reason why people turn atheists is because they want to feel like they are the ones who are in charge. Yeah. So I think basically humans have a natural tendency to gravitate towards power. That is why there are conversations around AI that are very skeptic in nature. But actually, when you look at, there are very many other conversations that make AI sound good to human life. Sound good to human life because imagine where you have nurses or nursing systems, that can nurse babies, yeah, that can nurse babies. Um, there is a movie called Mother. There's a movie called Mother. Mother, just mother, like the mother, your mother. So Mother is a movie that shows a child that was raised by a robot all their life. They were taught everything by that robot. Yeah. So basically, when you look at super AI in that sense, then it will look like an optimistic area to venture in. But if we look at it at a skeptic level, we'll fear it. Yeah. If we look at it at the Terminator kind of level, or Terminator or Transformer, yeah, those kinds of movies that show that dystopian movies that show um, an apocalyptic end that has been caused by robots. Yeah. Human civilization has been ended by robots, and it's now robots who rule the earth. If you look at it that way, we'll always be skeptic of what robots can or cannot do. But if you look at it in the manner in which they can help us, probably we can move. But again, as I say, there is a lot of concerns. So these concerns have to be looked into, and these concerns are not even professional in nature. If you want um, good output for your professional area, you have to use AI. Yeah, because they can produce great output. They can make predictions, and they can also calculate better. They can produce more accurate results. But so professional issues are not the concerns here, because AIs will do very well professionally, but the issues are ethical. How are they going to relate to us, yeah, without overrunning us at some point? So those are ethical issues that are basically an area of concern in super AIs. So it's actually very, very, it's a big area that is still being researched. But basically, just remember, I want us to remember narrow AI. Narrow AI is the one where they have just been built for a specific task, nothing else. General AI, they have efficiency like humans, like expert systems. But super AIs, they have consciousness, they have feeling, they are self-aware, and they can learn from experiences. All right. So that is basically a very, very, very simple example. A very simple example of or not an example really, but just a summary of what we've just learned. Now I'm not going to go into the others with these ones. I'm not going to go into reactive machines, limited memory, theory of mind, and self-awareness. I'm going to require you to read those on your own, but the ones that are very important are narrow AI. So if I ask you what are the types of AI, if you give me these three, narrow AI, general, and strong AI, you will have given me the the descriptions for the types of AI. All right, so Mulongo says, what if aliens we are for our AI? What do you mean, Mulongo? I cannot understand your statement. What if aliens we are looking for are AI? Well, who knows? Nobody has been out there and seen an alien, so I don't know. I really can't tell. And if there are creatures out there, I don't know if it is us who will. I don't know if it is us who will discover them. I don't think it is us, and I don't think they are AI. Yeah, I think they are biological, organic, or biological organisms like you. You have a reproductive system, a digestive system, a respiratory system, a nervous system. Yeah, psychomotor system for movement. You are biologic in nature. You have blood. You have cells. So I think if there are aliens out there, they are not AI. I think they are organic in nature. Yeah. You know, the world, the natural world is only made up of two things: organic things and non-organic. Organic are the ones that rule, or they are the ones that reproduce. Non-organics are things like stones, rocks, water, yeah, and air. They can't reproduce. So I think if there are aliens out there, they are not AI, but that is an area that we are not looking at. I think they are just organic. If there are creatures out there, they are organic. Yeah. Oh yeah, what types of AI are the robots that were sent to space to collect data? I'd actually promised to look that for you. I will still look that for you. Let me see. I think it was. Let me see. Let me see that here, so that I can answer you in the written. Let me share this. Let me share this so that you can follow. So you can follow that link and read more about that. Yeah, how NASA is researching on better AI systems to to do better space exploration. So you can actually go through that, and it will answer your question. All right. So any questions before we go to chapter 2? Any questions before we go to chapter 2, intelligent agents? Any question? Any questions before we move to chapter 2? Any questions before we go to chapter 2? All right, if there is no question, I think now we can move to chapter 2. Let me share the screen so that we can move together. Or can we have a break? What do you think? Personally, I need a break. I think I've talked a lot. A 10 minutes break, will that be fine? So that we can now come and introduce chapter 2. All right then, let's have a 10 minutes break.
resulting in catastrophic changes to human civilization.
Evolution going into an exponential rate.
Let's be back.
Scientists used to think we were
Our 10 minutes
decades
break is
away
over.
from achieving the singularity. However, recent advancements in artificial intelligence that
Our
they
10
thought
minutes
were
break is
decades
over.
away have actually come to fruition, suggesting that.
So let us be back. There is a very short video that I've uploaded into your portal about what would happen if we developed super intelligence. If we develop super intelligence, what would happen to us humans? What would it mean to us humans? What would it mean to our professional venture? And what would it mean to our ethical life, to our normal day-to-day life? So there is a video that I've uploaded. You will see it. You can see it when you access the portal in artificial intelligence. When you access the unit, you will see that. So you will actually see it. It is already there. I've uploaded. Now there's also going to be some other links that I'm going to share with you. Some YouTube links that I think might be important for you to to study the issue of AI and especially super intelligence, because that has been it has been the meat of our conversation for this morning. So you will find also some other links, some YouTube links. One of the two of them, I will share two specifically that you can access. They are actually large videos. The one that I've shared is just 4 minutes. The one that I've shared is just 4 minutes, but I will share a link that has it almost looks like a documentary. There's a big file that I may not be able to download with the the kind of bundles that I'm using. Yeah. And it may also take time to upload. Yeah, but I will share the link itself so that you can follow. But basically, whether we have a future or not in artificial intelligence, it is arguable. It is arguable. It is very, very arguable if we have a future in super intelligence or not. Arguable because there are people that are for it and there are people who are not for it. But this will require a lot of positivity. It will require a lot of professional mindedness, and it will also require to work with people from other fields, experts from other fields, to see how super AI can be integrated into real life so that it can help us more than it can help us and not eliminate us, as we have just discussed. All right, let's I want us to introduce something in chapter 2. Intelligent agents. So let me share this screen so that we can move together. Sorry, let me share this screen. So we'll basically introduce the topic because we already done with chapter 1. So I'll introduce chapter 2, which we are going to continue in the next class. All right. So intelligent agents. So this is where we are. Intelligent agents, chapter 2. Now, what is an intelligent agent? An intelligent agent is anything, whether living, that is whether organic or non-organic, that can perceive its environment through sensors, all right, and can act upon its environment through actuators, all right. An agent does this by perceiving, thinking, and acting. Perceiving, thinking, and acting. So let me repeat: an intelligent agent is anything, whether organic or non-organic, that can think for itself, it can interact with its environment, and it can able to receive input from its environment, and it is able to give back output. Now, there are 3 basic things that make an agent an agent.
there are three basic abilities that make an agent an agent. Number one is the ability to perceive. To perceive is to feel or to receive input. All right. And then the ability to think. To think is to reason, is to use the input it has received to build relationships. All right. And then acting is to solve a problem or to respond to whatever it has thought. Right. Now, there are three kinds of agents. There is a human agent, a robotic agent, and there is a software agent. In fact, I should have grouped them like a human agent, software agent, and robotic agent, right? Now, so an agent being a thing or anything organic or non-organic that can interact in its environment, it can perceive its environment, it can think, and it can act on its thoughts. That is what an agent is. It requires some particular things. Whether it is a human agent like you are an agent. Why? Because you can interact in your environment, you can think, you can also act on your environment, right? Yeah. And we are going to discuss the other two, software agents and robotic agents. But what makes any agent, whether organic or non-organic, whether it's a human or a computer system, what makes it an agent? We have said because of the three abilities. It can perceive, it can think, and it can act. But what makes it perceive? An agent is able to perceive because it uses sensors. So there are three parts of an agent that are very important. Number one, sensors. Sensors are parts of an agent, physical parts of an agent or virtual parts of an agent that make it that help it to receive inputs from its environment. Sensors, all right, that enable it to receive input from its environment. They are called sensors. Now let us look like at a human agent, because I think a human agent is the basis of our discussion. In other words, it is from where now we can understand the other agents. So a human agent has sensors. Sensors are basically what can receive input. What can you see with you use your eyes? So eyes is a sensor. What does it receive? Visual input. You have your skin. Your skin is a sensor. Why? Because it can receive touch. Yeah, you can feel when something or someone touches you. You can feel temperature. You can feel heat. Yeah, you can feel cold. So your skin is a sensor. Your ears are sensors. What do your ears receive? What kind of input does your ears receive? Sound input. Yeah. So in whichever manner your body receives input from your environment, in that manner or that mechanism or that physical thing that can receive input from its environment is a sensor. You can also your tongue can receive taste, yeah, input of taste. Yeah. So you as an agent, you have sensors, things that can interact with your environment, and those are called sensors. Your eyes, your sensory system, your audio system, your visual system, your audio system, your touch sensitive system, your taste, and your sense of smell. You can smell things through your nose. Yeah. So you are an agent because you have sensors. All right. Then through what you receive through those sensors, you are able to think. All right. So what makes you think? Your brain. So you as a human agent, your thinking goes on in your brain. So your perception goes on through your sensors, the different kinds of sensors. Your thinking goes on through your brain. So when you smell the smell of food, your brain will tell you that there is chapati being cooked or something, or like there is chips being fried, or there is meat being fried. And then all of a sudden you will begin probably feeling hungry, or there will be a certain kind of thing that there's a way your body will respond. So there's a way you think about the things you receive through your sensors. Yeah. Or when you see a good car, yeah, when you see a good car, you begin thinking about how that car can run fast, how comfortable that car can be inside, how much that car can cost. So you see now those are thoughts that are revolving around what you have just seen, or you hear news about politics in Kenya, yeah, and then you can think about things like how the government runs, how the government uses its money, how the government endorses some certain political parties, those kinds of things. So through what you sense, you are able to think some things, and you think through your brain. So your brain is your area of thought. All your thought processes occur in your brain because you are a human agent. Then you are able to act. Now, to act is to perform an action that is corresponding to what you have thought. To perform an action corresponding to what you have thought. So, for instance, if it is you felt through your nose the smell of food or the smell of meat being fried, and then you thought, this is meat, it has been fried in a certain way. There are thoughts that are going to go through your mind, yes, and then you are going now to act in some way. For instance, you are going to go to the kitchen to find out what is being cooked, yeah, or you are going to be looking for money to look for meat for yourself also. So there's a way you actually respond based on the different percepts or the inputs that you receive through your sensory organs. So an agent is an agent because number one, it's able to receive input through its sensory parts, and it is able to think, and it is able to act on its thoughts. Okay, so an intelligent agent is only an intelligent agent if it is not being remote controlled. If an intelligent agent is being remote controlled, then it's not an intelligent agent. It is supposed to be able to receive input on its own, it's supposed to be able to think on its own, and it's supposed to be able to act on its own based on some certain inputs it has received. Now, the input that comes through the sensory organs of an agent are called percepts. They are called percepts. Percepts written this way. Percepts. A percept is an input. A percept is an input that comes through the sensory parts of an intelligent agent. Okay? Yeah. Now, having discussed human agents, then we can discuss the other the kinds of agents. There can be a human agent, there can be a robotic agent, and there can be a software agent. Now, a software agent is one that does not have physical sensors. It does not have physical sensors. It can use physical things, but it does not itself it's a software, yeah, but it can interact with other parts of the system that are hardware based, like the keyboard, the mouse, whatever the user uses to give it input. So a software agent is a software that is intelligent. For instance, let us just look at the Google Voice system, the Google Voice system, or the speech recognition by Google, which you can use to search. Now, Google being a search engine, it is intelligent in nature. Why? Because you can speak to it, right? It can support speech recognition. So, what is the sensor for Google search engine? The sensor for Google search engine, what is the part that enables it to hear? It is your what? Your device's microphone, or your device's whatever headphone feature. Yeah, that particular software that runs your headphone. Yeah, that is its sensor. It is able to sense what comes through that headphone feature. All right. Then it is able to think. How is it able to think? It has a knowledge base. Now, when we are talking about inorganic agents, we are talking about a knowledge base. Let me bring that up again. A knowledge base. So for human agents, we call it a brain. For other agents, software agents and robotic agents, we call them knowledge base. a knowledge base. So it's very important to note that it is a knowledge base. It is not a brain. It is a knowledge base where information is. So a knowledge base can be a database. You know, a database can be tables that have fields and rows, fields and rows. Yeah. So it can be a database. All right. So it's called a knowledge base. Yeah. From where it can get that information. That is why always when you search, it will always if it is a slow kind of system, you'll see it searching for the response, and it will display the response. For instance, for Google speech recognition, it can search. It can take time to, not a lot of time, of course, but you will see that there is a time period, a very small time period, a time frame for it to search. All right. So why? Because it is searching from its knowledge base. It is thinking, quote unquote, it is thinking. And then what is its actuators? Actuators are the parts of an agent that it uses to give output. Yeah. So for instance, for you, it will be your hands, your feet to run. If you see a lion, the sight of the lion is the percept. You think, what is the thinking that will go on in your mind? Danger. What will be the action? Run. What will help you to run? Your legs. So your legs are your actuators. Okay. So for a software agent like Google, you have given it input like applications of super AI. So you are searching using Google speech recognition, applications of super AI in 2020, applications of super AI in 2020. So it will search. So when it's searching, it is thinking, and then it displays. Now the display of all the outputs it has is called the action. But what does it use to perform that action? It uses your screen. All right, it uses your screen. So it projects all your output on your screen. So it has to have a synchrony mechanism where it can project the output on your screen. Okay, it can project your output on your screen when it finds. Then so the software agent is just like any other, just like the last time when we discussed that there are systems like Jarvis, there are systems like Zuri. Somebody said Zuri for Safaricom. There are other software agents, chatbots. Chatbots are also software agents, right? So software agents, they work by keystrokes and speech recognition. The only way they can receive input from the user is by keystrokes, mouse taps or mouse clicks, and speech recognition. All right. They can also receive input through other means like biometric means, like an AI system for security, a security AI system. It can receive your feature through face unlock. So your phone has a what? Your phone has a face unlock system. So when you look at your phone, it can actually make an image of your face. Yeah, and most importantly, your eyes, your face and your eyes, and it can tell it is you, and it can unlock or what? A thumbprint. Yeah. So these kinds of AIs that are these kind of intelligent agents that are software agents, they use keystrokes for input, mouse clicks, speech recognition, or biometric means. All right. Then they use a database to think, and this is called querying. I think you have already been taught introduction to database and probably advanced database system. So there is the feature, the query feature. Query enables systems to search or filter through information in order to display relevant information. Yeah, and then it uses your screen to display, or your speaker if it is giving sound output. Yeah, it's sound output, your speaker. So your speaker or your screen is the actuator. So remember that. Then we have robotic agents. Robotic agents. A robotic agent is one which is mechanical in nature. It has physical parts. So a software, it's virtual because it is a program. But a robotic agent is physical because it has mechanical parts that can be plastic, rubber, and metal. Okay, integrated with computer programs that run it. So a robotic agent can have cameras. Okay. For instance, like what? Like a car. Like a car can have cameras to see what is in front of it, like a self-driving car. An infrared range finder, yeah, in order to determine what things like distance. For instance, if a car is moving and a self-driving car is moving, it has to know when there is another car in front of it and overtake well. So how is it able to determine the distance between another object or even a pedestrian that is crossing the road? It uses infrared range finder, so as a sensor to determine the distance between it and any other object in its environment. Yeah, and other kind of sensors, all right, like sensors for sound. If another car hoots behind it, yeah, it can actually stop or it can act in a certain way. And then it has other actuators. For instance, I want you to tell me I've minimized this because because now we can just do our final discussion, then we close the class. I want you to tell me just a self-driving car, for instance, a self-driving car. What are some of the, or yeah, let's discuss a self-driving car as we finish the class. What are some of the actuators that it will have? We have said that it will have cameras. It will have cameras for seeing what is in front. Yeah. It will have infrared range finders for determining distance between it and other objects around it. Yeah, and also to determine where the lanes are. It can sense the lane. The lanes. Yeah, the yellow or white lanes. Tell me other sensors and other actuators that car will have, a self-driving car. So remember, the sensor is a part that it uses, or a mechanism it uses to receive input from its environment, right? And then an actuator is a part or a mechanism that an agent uses to act on its environment. So what are some of the actuators and sensors for a self-driving car? Okay, route information will be in the knowledge base. That information will be in the knowledge base. Thank you, Saruni. Yeah, that information will be in the knowledge base. Mwangi Jefferson. There are people who have not talked today. Omuchenyi Davis. Collins. Morota. Kimathi Stacy. For instance, let me make it easy. How will a self-driving car know that another car is approaching from behind? Yeah, lane assist to help the car identify the road markings. So the lane assist is basically an infrared range finder. All right, it's called an IRF. Right, an infrared range finder. Its work is basically it uses infrared waves. I think you did networking, microwaves, infrared, satellite waves, those kinds of things. So it uses an infrared to look at the lanes so that it cannot pass its lanes. It can keep in its lane. Yeah, infrared range finders. Yeah, to see the lanes. What does a car use to accelerate? When it needs to accelerate, when there is no other car in front of it, it can accelerate. What does it use to accelerate?
It is a self-driving car. Alright, Collins back camera with sensors will determine the range of approaching car from behind. Yes, a camera, back camera, that is true. And so that will be a sensor. Okay, that will be a sensor. So whatever an agent uses to receive input from its environment, it's a sensor. Adaptive accelerator control, yes, it can even use accelerator pedals. It is a normal car, but nobody is driving. It has pedals, it has a brake pedal, it has a clutch, it has an accelerator, but nobody is actually driving it. Okay, like the concept of Tesla and Tesla self-driving cars. They are normal cars that actually have a steering wheel and pedals, but there is nobody who actually drives. So the pedals just move themselves. Okay, it is a code that enables them to move themselves. So yeah, there is some type of adaptive accelerator control and even accelerator pedals. Geolocation sensors via satellite for locations, yes, for destinations. So it will use a what? A GPRS system. It will have a GP. So that GPRS system is a sensor. Its work is to basically do what? Receive input about its location. Yeah, GPRS system. RFIDs. RFIDs will be what? Then speed governor installation for acceleration. So speed governor is a what? Speed governor is an actuator. Okay. Speed governor is an actuator. An actuator is what makes the agent, the intelligent agent, do what? Respond to its environment. All right. Yeah. And then Kimathi starts the adaptive accelerator control, or even physical accelerator pedals, which are programmed. Yeah. Physical accelerator pedals, which can be controlled by a system, not a person. That is a what? It's an actuator. Okay. A steering wheel is an actuator. Emergency braking is an actuator. Yeah. Emergency braking system is an actuator. Yeah. So an actuator is what makes an agent to respond to its environment. All right. So with that knowledge now from next time we are going now to look at the different categories of agents, okay, and see what are some of the things, what are the other concepts about agents. So the thing that we need to borrow from this class about intelligent agents is an intelligent agent is an intelligent system that is able to think on its own. It's able to perceive its environment, think on its own, and act in its environment, yeah, using sensors, knowledge based, and actuators. And then there are three broad categories of agents. They can be organic or inorganic. At organic, we have human agents, that is you, humans. You have a level of intelligence. You can receive input through your eyes, your visual senses, your sight, smell, hearing, and such. You have a brain to process or to think. That is your knowledge base. And then you have actuators like hands. You have your legs. You have your different faculties, your different parts of your body, which help you to respond to different things. Okay, and then there are inorganic or non-organic agents. These are artificial agents that have been built by humans. So we have robotic agents and software agents. Okay, software agents, their sensory mechanisms come through keystrokes, speech recognition, and biometric recognition like thumbprints and retinal scans. things like that, and then they give output through your screen, your computer screen, or sound output through speakers. Then robotic agents, they have things like cameras for sight. They have things like microphones for what? For sound. Yeah. They have things like thermostats. Thermostats for what? For temperature, to measure their temperature, to or thermometers or barometers to measure such kind of things like pressure, thermometer, things that they have to feel in the environment. Yeah. So that is basically it. That is basically it for today. So we're going to continue from there from the next class. So I think we can stop at that. Any question? Any question? Any question? Okay. If there be no question, I wish that we stop at that. Then we meet in the next class next week. All right. Have a good day. Let's meet next Monday. Please, before we go, please look at your portal in artificial intelligence. Look at the video I've uploaded there and also other links that I've shared so that you can look at the concept of super AI better. All right. Okay. Have a good day.